Hello and welcome to AdaPulse, the channel that brings you all the news and all the proposals that are in and around the Cardano ecosystem. Now today we're talking about Oura, the Tail of Cardano, which is a piece by LIBERLION you can find on the AdaPulse website. I'm Josh from ATM, let's go. Oura is a tool for pool operators, developers, and anyone who wants to find information on the blockchain. There are currently tools for exploring the Cardano blockchain, which are useful for when looking for standardized or generic information. But the Aurora use case is complementary, looking at the blockchain for particular patterns or particular events. Oura is, in essence, a tool to process information from certain events. A pipeline that connects to the tail of a Cardano node via some Ouroboros mini protocol combination filters events that match a particular pattern and then send a payload succinct, self-contained utility to pluggable observers called sinks. Now, Oura is a native implementation of Rust, which is a lightweight, compiled, general-purpose, multi-paradigm programming language that supports pure functional, procedural, imperative, and object-oriented programming. Oura is open source and licensed under the Apache 2.0 license. This tool processes the events in stages, and each one fulfills a different function, which we'll go through later. So why Oura? Ouroboros, the Cardano consensus protocol, is a reference to the ancient symbol that represents the serpent eating its own tail. The term Oura is of Greek etymology and means tail. The tool is inspired by the tail command available on Unix-like systems, which is used to display the tail of a text or piped data. So how does Oura work? So all of the heavy lifting required to communicate with the Cardano node is done by the Palace, which provides an implementation of the Ouroboros multiplexer and some of the necessary mini protocol state machines, chain sync and local state in particular. Palace is an expanding collection of modules that re-implement common Cardano logic in native Rust. This crate doesn't provide any particular application. It's meant to be used as a base layer to facilitate the development of higher level use cases, such as explorers, wallets, things like that. Who knows, maybe even a full node in the faraway future. The data pipe makes heavy use of the multi-threading and MPSC pipes provided by the Rust library. Oura connects directly to the Cardano node using TCP or Unix sockets. Each stage of the pipeline plays a different role. Now check this graphic that illustrates the order of the different stages. So source stages is responsible for extracting the data from the blockchain and mapping the raw blocks in search of smaller and more granular events. Each event is then sent through the stage's output port for further processing. Filter stages receive individual events from the source and apply transformations to each of them. The applied transformations will depend on the particular use case, but they will usually revolve around the selection of relevant events and their enrichment with the additional information, selecting the relevant events, enriching the events with external information, and adding metrics, etc. Sync stages receives the final version of the events and sends the payload to an external system, database, or service for further processing. For example, Kafka, Elasticsearch, or a custom HTTP endpoint. Or allows you to use one of the built-in syncs or create your own. Data flow. Now take a look at this image that shows the data flow, starting from the Cardano node until reaching the searching user through the web interface. So what are the use cases? There's quite a few, so I'm just going to summarize quickly. Firstly, the command line interface, or CLI, to view transactions live. The CLI tool of the node is like the Swiss Army knife of the system, which allows querying node to obtain information, send transactions, build and sign transactions, and manage cryptographic keys. Oura can watch the node socket to print transaction data to the terminal from the tip of a local or remote node. It can be useful as a debugging tool for developers or just to see what's happening in the network, like to watch airdrops as they happen or oracles posting new information. As a bridge to other persistence mechanisms, like the well-known dbsync tool provided by ORHK, Oura can be useful as a daemon to follow a node and send data to it. So a daemon is a special type of program that runs in the background. The main difference from DB-Sync is that Oura was designed for easy integration with data flow pipelines rather than relational databases. Given its small memory and CPU footprint, Oura can be deployed alongside your Cardano node, even in resource-constrained environments such as Raspberry Pis and the like, as a custom action trigger. Now, Oura in daemon mode can be configured to use custom filters to identify particular transaction patterns and trigger actions when a match is found. For example, send an email when a particular policy asset combination appears in a transaction. Call an AWS Lambda function when a wallet delegates to a particular pool. Send an HTTP call to a webhook every time a metadata key appears in the transactions payload, as a library for your custom scenarios. So if the available features don't suit your particular use case, Oura can be used as a library in the Rust project to configure custom pipelines. Each component of Oura is intended to be self-contained and reusable. For example, custom filters and syncs can be built by reusing existing sources. With Windows. Now, Oura's Windows support is currently experimental. The Windows build only supports node-to-node source with TCP socket bearer. Scraping metadata. One of the potential use cases for Oura is scraping metadata. This is a reference app to show how Oura can be leveraged to build a search engine for CIP25 tokens. The front end is built using React and Remix. The back end is a combination of a Cardano node, Oura, and Elasticsearch. Everything together is deployed using Kubernetes. Installation for the experts. Now, Oura provides different installation options that I will go through now. 1. Binary release. To use one of the pre-compiled binary releases for the supported platforms. 2. From source. To compile a binary from source code using Rust's toolchain. 3. Docker. To run the tool from a pre-built Docker image. 4. Kubernetes. To deploy Oura as a resource within a Kubernetes cluster. Currently, Oura does have limitations. That's why the development team is working on certain improvements. Oura can only process blocks from the Shelley era. So developers are working to add support for Byron, which is before the Shelley era. And that's to come in future releases. Oura does read minted block transaction events, but support for mempool querying is planned for future release. Oura will report chain backtracking as a new event. The business logic to undo already processed events is the responsibility of the consumer, but the team will add support for a buffer or filter stage that will retain blocks until they reach a configurable depth, basically a certain number of confirmations. And the latest release will be in the description below. So who are the developers? First we have Santiago Camullega. Now you say that fast. Santiago Camullega is Argentinian and is the leader of the project. His main collaborator is Mark Stopka, but here's a quick glimpse of the whole team. DC Spark have also started contributing to both Palace and Oura as well, so it's worth adding. Right, and that's the end of today's episode. Remember, the full article in print can be found on the AdaPulse website, and I'll be putting a link below. Please do like, share, subscribe by hitting the button up there. It does really help us out. And do comment below. That is really good for our metrics, so that helps us out too. And we also love hearing what you think. Now, you can further support us by delegating your ADA to Swag, Zod, or ATM. I'm Josh from ATM, and I'll see you next time. Thanks for joining us.